So homework day 34, continuing on with factoring. We're factoring a difference of squares. V squared is a perfect square. 36 is a perfect square. There's a minus sign in between. And if you remember when we were multiplying our binomials, we had that special case that came out to the answers that were factoring the difference of perfect squares. They were when you multiplied values that were conjugates. But when you take the assessment, you may or may not recognize that that's one of those special cases. And so you look at it and say, oh, I have a quadratic expression because I have that squared term that usually comes from factoring two binomials. So doing that foiling stuff. So factoring it the exact same way we did the ones on page 33. Factors of v squared, v and v. The end sign is a negative. If the end sign is a negative, I have to have one plus and one minus. What we want is the factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. That has a whole lot of pairs as factors, but we want the pair that gives us 0 in the middle. So we end up with the pair that has the same numbers, because if we have a plus 6 and a minus 6, we get 0 in the middle. So here we end up with what they call those conjugates, the same two terms just with opposite signs. If we wanted to check it, we would just FOIL it out. And so v times v is v squared. V times a minus 6 is minus 6v. Positive 6 times v, so positive 6v. Positive 6 times a negative 6 is my minus 36. My middle terms are opposites. They cancel out, so I get the v squared minus 36. So that indeed, v plus 6 times v minus 6 is my answer. So if I recognize when I look at it as the difference of perfect squares, then when I'm looking at the factors, I know it has to be that fair pair of factors that are the same numbers. So, number 2, if I'm going to factor that, hopefully I recognize it's the difference of perfect squares, but if not, I go to the foiling thing. Factors of z squared, z and z. Since the end is a negative, we have a plus and a minus. We want the pair of factors of 49 that are the same, that will end up giving me 0. So 49 would be 7 times 7. A positive 7 minus 7 is the 0 z's in the middle. So z plus 7 times z minus 7 is my conjugate pair that I'm going to get for my answer. Number 3, if I'm going to factor that one. Again, I'm going to have my 2 sets of parentheses. Factors of 16 first. 4 times 4 is 16. The end is negative, so I have a plus and a minus. Factors of w squared, w and w. So that I get a negative 4w plus a 4w, which is 0 w's in the middle. So if you can start recognizing, oh, there's only 2 terms, are they both perfect squares? Then it makes your factoring a little easier, because you know you should get conjugates, the same 2 terms, just with the opposite signs. Number 4, we're still factoring a difference of squares. They just made them a little bit harder to do, but the same type of thing. 49 is a perfect square, 36u squared is a perfect square, so hopefully you recognize when there's only 2 terms that it might be the difference of perfect squares. Factors of 49 then, 7 and 7. The end is a negative, so a plus and a minus. Factors of 36u squared, I'd have to have a 6u times another 6u. Again, if we want to check it out, we're going to FOIL it. 7 times 7 is 49. 7 times a minus 6u is a minus 42u. Positive 6u times 7 is positive 42u. Positive 6u times a negative 6u would be negative 36u to the second power. The middle terms end up being opposites. They cancel each other out. So we get the 49 minus the 36u squared. So 7 plus 6u times 7 minus 6u, going to be my answer. Number 5, same type of thing. There's only 2 terms. Both of them happen to be perfect squares, so I know it came from FOILing. Factors of 9u squared. 3u times 3u. 3u times 3u is 9u squared. The end is a negative, so we know one's a plus and one's a minus. Factors of 4, 2 and 2. So we get 3 plus 2u and 3 minus 2u for our answers. And then one more of those with the difference of perfect squares. 36 minus 25z squared, so factors of 36. 6 times 6. My signs, 1 plus and 1 minus. And factors of 5z squared, or 25z squared, is 5z and 5z. And so 6 plus 5z and 6 minus 5z, my answers. And if you had your signs in the opposite order, that's okay too. As long as one's a plus and one's a minus, you're okay. Get to the right problem here. Solving an equation written in factored form. So if my equation is factored out and set equal to 0, instead of having to try to multiply it out and do a whole bunch of solving, the easier thing to do is to make 2 separate problems. We know that anything times 0 gives me 0. So either the u minus 2 could equal 0 or the u minus 1 could equal 0. Well, we're going to solve these just like we solve everything else. We've got to move our 2 to the other side. So we're going to plus 2, and 0 plus 2 just gives me 2. Here I have to move my 1 to the other side. I'm going to add 1. 0 plus 1 is 1. So if I check that out, if I put my 2's in, 2 minus 2 is 0. 2 minus 1 is 1. But 0 times 1, hey, is 0. That checks out. If I happen to do the other one, put my 1's in, because that was my other answer. 1 minus 2 is negative 1. 1 minus 1 is 0. Negative 1 times 0, guess what, is 0. So they tell you if there's more than one solution, which there is, you're going to separate them with commas. So u is going to equal 2 or 1. Doesn't matter the order, just so you have them both in there. And there are my answers. So if it's in factored form and it's equal to 0, then you can just break it down and put each factor equal to 0 and solve. Number 8, solve for v. You have 3 times v plus 2 times negative v minus 1. Now if I'm solving for v, the 3 doesn't have a v with it, so there's nothing there to solve. So I can just ignore that that 3 is even there. I'm going to say either the v plus 2 could equal 0 or the negative v minus 1 could equal 0. So solving this first one, I'm just going to minus my 2 and move it to the other side. V equals negative 2. Now on the next one, couple different ways you can solve it. If we solve it our normal way, we say, oh, I got to plus my 1, so negative v equals 1, but then I have to remember to get rid of the negative side. I'm dividing by negative 1. 1 divided by negative 1 gives me negative 1 for my answer. The other way to do that is if you happen to recognize that this one is negative, the v is negative. Remember we did this in the solving equation section. No, you probably don't remember. Is move the v over instead of moving the number over. Since the v is negative and you want it to be positive, I'm going to add my v. If I do that, I just get negative 1 equals v. Now this was a whole lot shorter to do than this was, but we get used to solving equations all in the same way, so if you don't like to change your methods, this works. Otherwise, this is your shortcut. So again, we get 2 solutions, v equals negative 2 or negative 1, because we had 2 different v's that we needed to solve for. Now, by the way, if there is a variable with that 3, then you do need to set it equal to 0 and solve it. So if it said 3v equals 0, you would then go ahead and solve that. You get 0. Number 9, I'm going to solve that for you. So again, I've got 2 sets of factors here. And so I'm just going to change this problem just for fun so that you have an example. If I have, say, 2u in front of that. I'll type it in there. You'll just have to write it on your paper. I'm going to clear my ink first. There it is. There, we'll solve that instead. If I have something that looks like this, 2u times 3 plus u, now my pen, okay, it wasn't the smart ink, there it goes. My thing here has a u in this term, a u here, and a u here. So I'm going to end up with 3 answers. I'm going to say either the 2u could equal 0, the 3 plus u could equal 0, or the 2u plus 9 could equal 0. So if I solve this one, I have to divide by my 2. 0 divided by 2 is still 0. If I'm going to solve this one, I've got to move my 3 to the other side, so I've got a minus 3. 0 minus 3 is minus 3. And then if I have this one here, I have to minus my 9 first. 2u equals negative 9. And then I have to divide by 2. This one I can't simplify other than I write it as negative 9 halves. So in this case I end up with 3 answers. U could equal 0, negative 3, or negative 9 halves. And I put them all in. So, the reason we did that is because when we have a quadratic expression, instead of trying to solve this craziness for 0 by doing a whole bunch of guessing or whatever we might try to do, is that if we can put it in factored form like the previous ones, then we can solve them and find the answers. So we're going to start out by saying, okay, it is equal to 0. That's the first key. Then we can factor. So we put our 2 sets of parentheses. Factors u squared, u and u. The end is a positive, so both signs have to be the same as the middle, negative and a negative. Factors of 6 that add up to 5. Well, 1 and 6 don't add up to 5, but 2 and 3 do. So a negative 2 and a negative 3 add up to my negative 5 in the middle. It's equal to 0. Now I can say, oh, then the u minus 2 has to equal 0, or the u minus 3 has to equal 0. So solving that, I would add 2 and get an answer of u equals 2. Add 3, so 3 would be my other answer. What does that mean? If I put these numbers in for the u and solve it, I should get the 0. So if I did 2 squared minus 5 times 2 plus 6. 2 squared is 4. Negative 5 times 2 is negative 10 plus 6. Excuse me. Negative 4 minus 10 would be negative 6, and a negative 6 plus 6, sure enough, is 0. If I check the other answer, the 3, I would say, oh, 3 squared minus 5 times 3 plus 6. 3 squared is 9. Minus 5 times 3 is minus 15 plus 6. Excuse me. 9 minus 15 is negative 6. And a negative 6 plus 6, sure enough, is 0. And these are the only 2 numbers that you can plug in and get 0. If you try anything other than those 2 numbers, you're not going to get an answer of 0. So number 11, we're doing the same kind of thing. I'm going to get a quick drink here. We want to solve this equation. It is a quadratic expression, which means it has a squared term. It is set equal to 0, so we can solve by factoring it out. Factors of y squared, y and y. The end is a positive, so both signs have to be the same as the middle, a plus and a plus. Factors of 3. Well, there's not a whole lot of choices. 1 and 3. A positive 1 and a positive 3 add up to the 4 in the middle. So either y plus 1 equals 0 or y plus 3 equals 0. Solving those, we're just moving our number to the other side. So I'm going to minus 1 and minus 3. So y would equal negative 1 or negative 3 for my answers. And again, you could substitute them in and see, do I really get 0? I bet you do. Number 12. Again, I'm solving it for x. I have a quadratic expression. It is set equal to 0. So I'm going to solve by factoring factors of x squared, x and x. Since the end is negative, I have to have 1 plus and 1 minus, one of each. Positive times a negative is a negative. Factors of 3. 1 and 3, but here it'll make a difference. I want to end up with a positive 2, which means my bigger number has to be positive. A positive 3 minus a 1 gives me positive 2 in the middle, and that's equal to 0. So either the x plus 3 equals 0 or the x minus 1 equals 0. I have to finish and solve those by moving my numbers over. So in this one I'm going to minus my 3. On this one I'm going to plus my 1. So x is going to equal negative 3 or positive 1 for my two answers. And then 13, 14, and 15. Now they make them even more complicated. We want to solve this, but they don't have it equal to 0. So what you want to do is you want to look. Whenever you have a squared term, your first step is you want to get it set equal to 0. If I'm going to set it equal to 0, I always want to leave my squared term so that it's a positive number. We have not factored a single thing that had a negative x squared term. So we need this to be positive, which means I'm going to move both of these to the other side. So I'm going to have 5u squared. Since this is a positive 9u, I'm going to make it a negative 9u. And since that's a positive 2, I'm going to make it a negative 2. And I'm going to set it equal to 0. Make sure you have it in descending order, your u squared, your u term, and then your number, your constant term on the end. Now it's in the proper form that we can factor it. So we use our two sets of parentheses. Factors of 5u squared. Well, 1u times 5u. So u times 5u is 5u squared. My signs, since the end is negative, I have to have one of each sign, a plus and a minus. I may have to switch them, but I'm going to start that way. Factors of 2. Only way to get 2 is 2 times 1, but of course the order would be important. If I put my 2 and my 1 in here and I check it, I'm going to have here negative 1u. Inside, I'm going to get a positive 10u. 10 minus 1 is 9. I want to get negative 9, which tells me my signs are backwards. So I'm going to make this the negative and this the positive so that I get a positive 1 and a minus 10. And 1 minus 10 is negative 9. That's equal to 0, so now I'm going to break it down into the two problems. U minus 2 equals 0, and 5u plus 1 equals 0. Well, that first one's pretty easy to solve. All we have to do is move our 2. So we're going to add our 2, so u equals 2. Second one, we've got the 2 steps to solve. We got to move our 1 first, so minus our 1, 5u equals negative 1, and then we still have to divide by our 5. So u is going to equal negative 1/5. So again, we get 2 solutions, 2 and negative 1/5. Number 14. Again, I look at that, it tells me to solve it for w, I see that there's a squared term, and if that squared term's in there, normally I'm going to solve it by factoring, which means I have to have it set equal to 0. I want my squared term to stay positive, so I'm going to move these two things to the other side. So 9w squared, this is a positive 30w, so I'm going to make it a minus 30w. This is a minus 25, so I'm going to make it a positive 25. Now I have it set equal to 0. I can solve by factoring. So here, I've got 9w squared. It might be w and 9w, or it might be 3w and 3w. Until you have a whole lot of practice, you probably have no idea which pair it is, and you just have to start guessing. The end is positive. If the end is positive, both signs have to be the same as the middle, so we know we have a negative and a negative. Factors of 25. 1 and 25, but more likely it's the 5 and the 5. So I'm going to put the 5 and the 5 in, and I'm going to check it out. So here my outside is negative 5w, my inside is negative 45w. Nope, that's not going to add up to 30. I'm going to check the other one. My outside is negative 15w. My inside is negative 15w. So that's the one I want because negative 15 plus negative 15 adds up to the negative 30w in the middle. So, going to get rid of that one. It didn't work. This is the one I want, the 3w minus 5 times the 3w minus 5. Now notice these two things are exactly the same. Means it's going to give you the exact same answer. You don't have to put the same answer in twice. You only have to put it in there once. So I'm just going to solve 3w minus 5 equals 0. So adding my 5, 3w would equal 5, dividing by 3. So w is going to equal 5/3. That's known as a double root because you actually would end up getting it twice. But when you enter it in, you just put it in once. W is 5/3. All right. So number 15 says solve for V. If there is more than one solution, separate them with commas. If there's no solution, click on no solution. It's a quadratic expression. We need to set it equal to 0. So 3v squared. We've got to minus the 8v to move it over, and minus the 3, and it's going to equal 0. So I need to solve that by factoring. Factors of 3v squared, v times 3v. My signs, since the end is negative, I've got 1 plus and 1 minus. And the factors of 3, 1 times 3. So if I plug those in here and I put the 3 here and the 1 here, I'm going to get negative 1v plus 9v, which is a positive 8v, which tells me my signs are backwards. I'm going to make this one the negative then, and this one the positive. Checking that out, I'm going to get a positive 1v minus a 9v, and 1 minus 9 is negative 8v in the middle. So now I have it factored the right way. It is set equal to 0. I can set each of my factors equal to 0. So v minus 3 would equal 0, or 3v plus 1 would equal 0. Solving that first one, just need to move that 3 over. So we're going to add our 3, and v equals 3. This one we've got to do in 2 steps. We're going to move our 1 over first, which makes it negative 1. 3v equals negative 1. Divide by 3. And so v equals negative 1/3. So my 2 answers, v would equal 3 or negative 1/3. So solving my quadratic expressions, that means there's a squared term. We're going to set them equal to 0, factoring them out, and we should end up with 2 solutions, or maybe the same solution twice. And that should be the end of that chapter.